Good morning, good afternoon, good evening, whatever the case may be. We are back in better than ever and ready for Domain and Range Part 2. Let's get to it, shall we? State the domain and range for each of the following functions. Okay. Now, this gets a little bit dicey, not too bad. Sorry about that. Okay. So, when you have square roots, let's just talk domain real quick. We know that we cannot find the square root of a negative number. So we need to find out when inside of the square root, the x minus 5, when is that going to be less than 0? Not equal to, because we can take the square root of 0. So that would be when x is less than 5. So again, we can't, for x less than 5, we can't find the square root. So that would mean that the domain would have to be greater than or equal to 5. Set of x such that x is greater than or equal to 5. Okay, and so you can kind of check that in your head. 5 minus 5 is 0. The square root of 0 is 0. Checks the next integer. 6 minus 5 is 1. Square root of 1 is 1. Anything positive is good. If you want to check the other way, like substitute in 4 for x. 4 minus 5 is negative 1. We can't take the square root of it. Okay. So for the range, let's think about this. The lowest number we can have is a 5 for x. So let's just test that. The square root of 5 minus 5 is equal to 0. Square root of 0 is 0. Can we go any lower than that? And the answer is no, because 5 is the least number we can use. Square root of 6 minus 5 is square root of 1, which is 1. Is there any way we can go below? Can we get a negative? No, it's not possible to get a negative. So the range would be the set of y such that y is greater than or equal to 0. And let me show you that on the graph, the square root of x minus 5. Sometimes that makes things make a little bit more sense. Pay attention to how I graph this. There's my square root symbol right there. And then it's x minus 5, enter. And so we can see that right there, 1, 2, 3, 4, 5. It starts at 5, the x coordinate, and it goes to the right forever, which is what we said here, the set of x such that x is greater than or equal to 5. And then the lowest value clearly is 0. And, excuse me, the graph keeps on going higher and higher and higher, hitting using every point on the y-axis. And let's just find the 0 so we can verify that. We'll go here, and we do have the point 5, 0. So again, domain x greater than or equal to 5, range y greater than or equal to 0. Okay. All right, so let's take a look at part B, 1 over x minus 5. F of x equals 1 over x minus 5. So for the domain, we are looking for whenever, if we have a square root, whenever we're going to have a negative number, or under the square root, because we can't take the square root of a negative number. And for a rational function, we want to know when the denominator is going to be equal to 0, because that cannot be, because we cannot divide by 0. So I'm going to set the denominator equal to 0 and solve, and I know that you know that the answer would be 5. So what that is saying is when x equals 5, then denominator is 0. And we can't divide by 0. Can't do it. So therefore, x cannot equal 5. That's the only restriction on the domain. If you think about it, every single other number we can take 1 and divide it by it, except for 0. So that means that the domain would be the set of x such that x is not equal to 5. And that's good enough to put, because once we say x is not equal to 5, we know it includes all other numbers. Okay, so what about the range? What does that look like? What does the range look like? Well, let's test a couple of things. So 1 over, let's say it can't equal 5, so 1 over 6 minus 5 is 1 over 1, which is 1. Or maybe 1 over 4 minus 5 would be 1 over negative 1, so that's negative 1. Remember, I'm substituting in, so I'm getting y values. You might think, oh, okay, well, it's 1 or negative 1. But wait a second. What if it was, I don't know, 1 over, as this gets larger, like 1 over 10,000 minus 5. That's going to get pretty close to 0. Same as if this was negative 10,000 over 5. It would 1 over negative 10,005 is going to get pretty close to 0. Check it out on your calculator. Or what if x was really, really large? Like what if x was, really, really small? 3 minus 5, 2 minus 5, like 1 over a very small decimal point, like 0.00001. That's going to go sky high. So, but it's never going to be able to be equal to 0. So for the range, there's no way we're going to be able to get a 0. So the range would be the set of y such that y is not equal to 0. And let's take a look at that graph just to prove it. So that would be 1 over x minus 5. And let me put that in there. I love this part, control divide gives you a fraction in the graph thing. So 1 over x minus 5, bam. And there you go. You can see how the graph goes forever up and forever down, hitting all of these y coordinates, and how it gets closer and closer and closer to the x-axis, going all the way to the right and all the way to the left, but it never ever hits 0. Now it kind of looks like it's here, but that's just when our y coordinate is really, 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 really small. So that hopefully you can just kind of see that, and it kind of justifies in your mind why the domain and range are what they are. Okay. And a miracle occurs, the ink is gone. Square root of x minus 5. So we've already done all the hard work here. We know that x cannot equal 5 because that would mean 1 over 0, which we cannot have. We also know that x must be greater than or equal to 5 if I just look at the square root, because otherwise we would be taking the square root of a negative number. But from this, we know that x cannot equal 5, so we have to change this and say that x can be greater than 5. Greater than 5, okay? Because if it was equal to 5, we would have 0 in the denominator. Less than 5, where we can't take the square root of negative number. So the domain here is the set of x such that x is greater than 5. Okay. Range. Let's think about this a little bit. We are never going to get anything negative in the denominator. Never. And it's never going to be equal to 0 by the arguments that we made for both this one and this one. And we'll show it, you'll see it again on the graph. So it's gonna either be able to get super large as this gets smaller, or super small as this would get larger. So the range is the set of y such that y is greater than 0. Could never be equal to 0. And let's take a look at that graph, which hopefully kind of intuitively you'll see that it's really just going to be this part of the graph, because we cannot have any negative values for a function, because you can't take the square root of anything that's going to give you a negative number. Let's go ahead and put it in there. 1 over, let me get rid of that, the square root of x minus 5, and boom. Look, it's the same one, or close to the same one. There is a little bit of difference because of the square root. It's close to the same one. 1, 2, 3, 4, 5. And if you look, if we could put a straight line there, unfortunately I can't, you can see that it would never touch 5. But it's going to hit all of the y coordinates. If we were plotting the points here, we would need all of the y values. And let's just go ahead and show something real quick. Points and lines, point on, and I'm going to put a point on this graph. There we go. And if I grab it and move it, you can see how it's now, it gets closer to 5, but never gets there. But every y coordinate is being used except 0. And every y coordinate is being used going up this way. It's going to go all the way from 0 all the way up to infinity. Okay, hopefully that made some sense to you. I hope you enjoyed it. I know I did. And with that, I am out.